the maximum flux would occur when the field is pointing this way, in this case, and the area looks like this, with its area vector that way. Right? That would be the biggest flux you could get because theta equals 0. The cosine of 0 is 1. That is the magnitude of the E field times the magnitude of the A field. And if you just visualize the E field going through the surface, then of course that's the biggest value you can get. You can get less flux if you let it be at an angle. So say here is your E field, uniform E field, and now you draw it down here like this. And it's pointing down. Maybe it's at 45 degrees between the E field direction and the A direction. Then you're not going to get as large of a flux because the cosine of 45 is less than 1, square root of 2 over 2. And you can also see, yes, less field would go through because it's at an angle. Okay. You can also get 0. Right. E field, constant E field. What would you do? The area of the circle is just flat. If your area looked like that and your A vector were down, then nothing gets through. Right? The field vectors don't even see the area. They just see a flat, thin little thing. They don't get through because theta between the E field and the A is 90 degrees, and the cosine of 90 is 0. So those are the three cases. Now we have a question, and I'm not even going to answer the question. I'm not even going to acknowledge the question because I know what the question is from teaching this class for so long. I know that what you're going to say is, how do you know which way to make A? Right? I keep putting A over here. Why couldn't A be back here? Well, it can, actually. It's actually arbitrary in this case which way A goes. I could draw this surface like this, and I could say, no, A is that way. There's nothing special about this side or this side. Right? They're both valid sides. They're both valid ways to make A go. All that really means is you get negative flux. Right? If A is pointing towards E and you think about the angle in between, then theta is greater than 90 degrees. And if theta is greater than 90 degrees, the cosine will be negative. It can go all the way up to 180 and then it gets positive again. But you get the idea. It could be all the way to facing where it's 180 degrees and you get -1. So you can get this maximum value all the way from positive all the way down to negative. And which way you draw the area vector, it's really just a convention. It's like you're going to call this way plus x or you're going to call that way plus x. For little flat disks like this, it doesn't matter which way A is. Okay? For other surfaces, closed surfaces, then it becomes not so meaningless. You can always say out has to be positive A and in has to be negative A. But for these surfaces, it could be either way. It's really just which sign you want to give the flux.